Hello, my name is Josh Brister, and I'm here with James Sinclair. This is the Christian Resistance podcast, and what we are going to be talking about today is cosmic fine tuning and Big Bang cosmology, or physics, and how that shows the beginning of the universe. And what is more plausible? How do we explain the data better? Is it more plausible or best explained under theism, the belief that God does exist, or atheism, the belief that God does not exist? And uh, James, it's an honor to have you on. Just as in a brief introduction, um, can you say anything to the audience why you think this subject is important, or maybe you should start just with a 20 seconds or however long you want, just to tell who you are, just briefly, and why you think this is an important subject to discuss with others. How theism best explains the cosmic fine tuning and the very origin of the universe. Go ahead, James.
Okay, thank you for inviting me on. I got
Thank you.
started on this in the 90s. I'm a physicist who works for the government. I work on sophisticated models of the world, shall we say. And so I know a fair amount about mathematical chaos and things like that, and how they work inside physical models. And so that's my background. I came to Christ in Baptist church when I was in my early teens.
Mm,
I'm like a lot of folks that went through a crisis of faith.
yeah.
Once you go off to college and you learn this and that, and then you go back
Hmm.
and then you say, well, okay, Reverend, how do you respond to this? How do you respond to that?
Yeah.
And the
I completely understand.
Christian community is not that great necessarily, especially in that era, at responding to a lot of these challenges.
Yeah.
So in the late 90s, I came across the Reasons to Believe ministry, which probably
Mm.
a lot of your listeners know who it is. It's reasons.org.
Yeah, reasons to believe. That's a great Christian science-oriented organization.
It is astrophysicist Hugh Ross. He leads it.
Yeah.
Uh, Jeff Swearink, who I'm going to be talking about later, is another astrophysicist that they have on staff, who's written an excellent book about the beginning of the universe and what it has to do with Christianity. We maybe talk
Hmm.
about it. But at the time, that was the first real presentation that I saw that there the Christian belief system could be defended,
Hmm.
especially in light of modern science.
Yeah.
And I was involved in young Earth beliefs back then, and that was one of the big challenges. I won't get into that too much now,
Hmm. Yeah.
but the idea that that modern cosmology not only is it not incompatible with faith, but it seems to help. It,
Mm.
it seems to show. It seems to provide evidence in favor of theism. And
Hmm.
theism, I'm going to define here as the three Abrahamic faiths. So
Hmm.
you can't get directly to Christianity necessarily
Yeah.
from a cosmological argument, but you can provide evidence that there's one God. So it helps Judaism, it helps Islam, and
Yeah.
Christian. And if you want to go beyond that, the resurrection arguments are the best one for
Hmm.
Christian. In fact,
Well,
but I got involved in that, and given the psychological makeup, I'm an INTJ, Myers Briggs. If you're
mhm.
an INTJ, you have to prove everything. And you have to prove everything to yourself and others, and that can be a weakness as much as a
Yeah.
strength. Like my wife, my family, my wife, for example, came to Christ through a religious experience. Right? So
Hmm.
she doesn't need sophisticated science arguments. She thinks it's all very interesting and everything, but it's just not part of her makeup that she needs it. But there is a class of people out there, and a lot of them are engineers and scientists
Hmm.
and the like, who they're going to ask that question. Is this compatible with what we know, with what you can see about the physical world? So what's the first, when I came into contact with Reasons to Believe, I said, well, this sounds very interesting. From Missouri on this, show me, right? Show me state, right? So, and once you start getting involved, I think a lot of Christian apologists, defenders get on this. It becomes exciting, and you just want to devour everything and prove everything. And that kind of happened to me. And given my background and the fact that through my employ, I had access to physics journals and things like that, I started getting involved in the cosmology directly. And right about that time is the time that the internet took off. So the ARXIV website, you had preprints, and I had physics journals from everything that I needed right at the tabletop. So, and back then, and it's kind of still true now, it was not difficult to speak directly to cosmologists. Their email addresses would typically be on their papers because it's all about peer review. That's what they want to do. So I started interviewing them on this topic, and that's how I got involved in it. And then later on, I contacted William Lane Craig, and we started collaborating.
And that's particularly interesting, because how I found out about your work is through this book, The Blackwell Companion to Natural Theology. And you and Dr. Craig had written an article, or not an article, but an academic paper defending the kalam cosmological argument. Is a very sophisticated paper. But can you tell our listeners what the kalam cosmological argument is, and maybe just a little of its history and why you think it's so compelling, the kalam cosmological argument?
Okay, so the real power of the kalam cosmological argument. By the way, kalam is a Muslim word. It means something like doctrine or defense of the faith. And the reason people may wonder why we use that to honor some of the ancient scholars like Al-Ghazali. But there were also Christians and Jews that were involved in the argument. The argument goes back, I don't know, at least back to John Philoponus, which I think is the 4th or 5th century AD. Okay, well, there's a proto version of it. Maimonides for the Jewish faith was involved in the Middle Ages, and it's a proof for the existence of a transcendent creator. Okay, a lot when we're going to talk about fine tuning later. Also, the thing about fine tuning is you're talking about the universe or things that are in the universe itself, and as when we get to that, I'll say there is a reply that the atheist can give that's a little bit difficult to deal with, which isn't a problem for an argument for transcendence. Which if you have the metaphysical arguments like Thomas Aquinas or Kalam, it's specifically an argument to a transcendent creator, that there must be one which transcends in an ontological sense, not a locational sense, the universe. So it has 3 premises to it. It's a very simple argument. The proof and defense of the premises are difficult. They can be, but the argument itself is not. And the first premise is that which begins to exist must have a cause.
Okay. It's a very, very simple premise.
And you have to be very careful. It's not like everything has a cause. That's not things that begin to exist.
And I've often heard atheists say, well, the kalam cosmological argument can't be sound because, what's God's cause? But as you pointed out, it doesn't say that everything has a cause, right?
That's right. If you want to get, if you want to go there, now you're talking about the idea of necessary versus contingent entities in philosophy. And we would argue that God is necessary. So
Yeah.
doesn't have a cause, isn't contingent. Contingent means something like has a dependence on something else for its existence. Okay, so
Yeah.
and God would not be. Other things would be abstract objects if they exist, like mathematical objects, and
Yeah.
Platonism. Okay, so ideas. The Okay, so that's the first premise. The second premise
First
is
premise.
the universe has a beginning. Okay. Third premise is the conclusion. Therefore, the universe has a cause. I call that this simple kalam argument. And you can give corollary arguments, like Dr. Craig does in the article that you mentioned in Black Rock Companion to Natural Theology. You can give corollary arguments. Well, we think that this creator is omniscient and omnipresent and all these characteristics that we would say, and this is what we mean by God. How Dr. Craig wraps up that article. So it ends up being a pretty good defense of theism. I say that I defend 1/2 of the 1/3 of the argument, because the place that I assist Dr. Craig is the second premise, which is the universe began to exist, which you split into two halves. One of them is philosophy of time, which can be a difficult subject.
Yes.
Okay. So the idea there's a philosophy of time which we defend, called the A version, which is that time really flows. And here I'm just using a euphemism. These are not hard words, and they'll get picked apart by a modern philosopher. So I'm saying this for a general audience. Time flows, things evolve. Okay, so I just used the E word, which is scary to Christians. This is the irony, which I point out, and everyone doesn't get the point. You're actually giving a defense of the general concept of evolution, which is that things change with respect to time. Okay, which shouldn't be too scary.
Yeah.
It's actually the atheists who are opposed to evolution in cosmological arguments. So
you bring up the passage of time. I just wanted to say, I think that's so intuitive that change actually occurs. It seems to me that a person is well in his epistemic rights as a philosopher just to believe in change. So I would think the A theory of time has a good amount of prima facie reason to believe it. I think it's very philosophical, common sense. I'm sorry to interrupt you.
That's a good way to put it. I mean, it takes a modern philosopher to believe. You got to do a lot of work to disbelieve the eye test.
Yeah.
Now we can go into that and why a lot of philosophers believe in something called the B theory, which is the tenseless. It's tense versus tenseless.
Yeah.
Theories of time. That's the more correct way to say it. So tensed means if I say something like now, that's as opposed. What if I say August 3rd at 5 o'clock? That is a tenseless description of a point in time. But if I say a fortnight from now, something like that, then I'm putting tense in my language. What I'm saying is that there is a real present. And this is the philosophy of time that Dr. Craig defends, and which is a prerequisite for the kalam argument. And he defends, now there's different ways of doing that. It's possible, for example, to believe that the past still exists. This is called a growing block theorist. But there's also an objective present, and it's a block of time which constantly grows. Dr. Craig defends a view called presentism, which is that the past and the future don't exist. Only the present exists. Okay, so there's an objective, real present, and that's where you get into the, if we delve deep into the philosophy, the B theory, or the tense-less theory, does not believe that there's an objective real present. They believe that
Yes.
think of like a static block that just exists for all eternity, and it's just hanging. Think of it that way.
Yeah.
And that has parallels in relativity, especially special relativity, which is why a lot of philosophers, mathematicians, and physicists like it. Anyway, that's the first half of the second premise. We're going to get through it. Okay, I won't take it. I have a tendency to go off
Oh, you're fine.
flow like the river. Okay. The second half of that. Okay. So the universe did begin. Time is such that when things begin, they begin to exist. That's the aversion of time. Okay. So the second part of it is there's actually a beginning. So that is something that modern cosmology has something to say about. So actually, science. So now you've got, and science, whether we like it or not, this is the authority for where you get knowledge from in the post-Christian society.
Yeah.
And even in the 20th century, it was such a strong competitor, pretty much. And so, from a standpoint of talking to a modern audience, it's useful to come from that direction. But also, the evidence seems to point in the direction of a beginning to the universe, and therefore it lends evidence to theism.
Now, I think if I remember right, there's a number of pieces of evidence, and I want to see what you think of this for the beginning of the universe. I think thermodynamics and entropy somehow points to the beginning of the universe. The background radiation and the expansion of the galaxies, the red shift. Could you mix in all those, the thermodynamic properties, entropy, and so forth, and show how the universe began to exist?
Yeah, and those are two different lines of evidence. There's something called the standard hot Big Bang model, which as of circa, say, 1980 or so. By the way, the fact that that's 41 years ago does not mean it's ancient past, like ancient Greece or something. It's very much a part of the modern discussion. Throughout much of the 20th century, after Einstein derived the equations of general relativity, and at the same time, this is part of the Blackwell article, that the beginning of this section is all about the you could see, at the beginning of the 20th century, they weren't even sure that galaxies existed. It was only with modern astronomy that you could tell, and that there were certain methods for estimating ranges to things that showed that galaxies existed. And what was discovered alongside Einstein's equations is it looked like most of the objects in the universe were moving away from us, and the further away they were, the faster they were moving. So it was a lot like a two-dimensional analog would be like the surface of a balloon, and I'm blowing up. I put dots on it, and I'm blowing into it, make it larger, and all the dots get farther apart. And whichever dot you're sitting on, if you imagine you're an observer, you're going to see everything get further away from you. And the further away the things were, the faster they would get. So in other words, that surface looks like it's expanding.
Okay.
That's what it looked like. Now,
are you talking about Hubble?
Yeah.
Okay.
1929, circa, another guy named Slipher. And darn it, there's a famous female scientist whose name, it's in the article. I'm going to do that a lot. I'm going to forget names. That was significantly involved in this as well. The other part of that is Einstein's equations, which seem to show that the universe is in a dynamic state of either contraction or expansion, which was a big surprise. Because the prevalent belief prior to Einstein is that the universe is probably in some kind of steady state, and which could be eternal. Even a lot of religious believers believe that. Like John Aquinas said, well, we don't know what's going on. Maybe the universe is eternal or not.
Yeah.
It doesn't. The Genesis seems to say that there's a beginning, but you can argue it either way.
And that was Fred Hoyle, right? That was holding on to the steady state position.
Right.
Am I correct in that?
Yes.
Okay.
In fact, he's got modern adherents. I think Narlikar, I think is the guy's name, who I think is still with us and still arguing in favor of various types of steady state theories. But it gets increasingly difficult. It's very difficult to explain redshift evidence. If you just go online and look for it, and you'll find all kind of. The thing is, there's this thing called Occam's razor. The things that seem to point to truth are the simplest explanations. Okay, can something complicated be true? Yes, you can't rule it out. But the more you've got to put band-aids on your theory to keep it viable, the chances are it's going to end up getting disproven by observational evidence eventually. The heliocentric theory is a good example. The Ptolemaic. The Ptolemaic mathematical model works just fine. The Earth-centered. It's just very complicated math. So he said, no, that's not what's going on. Sun-centered, Earth is going around the sun. It was just so much simpler, had the ring of truth to it. That's what was happening to the steady state theory in mid to late 20th century.
Okay, and then Einstein came around. Are you talking about Einstein's general theory of relativity or special theory?
The general theory.
Okay.
Yeah. So circa, let's say 1915, I think is when that was derived. And Einstein didn't believe his own result. It's really strange. His equations predicted either a contracting or an expanding universe, and he believed in the steady state. So he put a arbitrary parameter in his theory, which he called the cosmological constant, in order to make it so that there was an exact balance between the tendency to expand or contract.
I've heard that also called the fudge factor. Is that correct?
Yeah. And then I think he called that his biggest blunder. And then it turned out in the late 1990s, it seemed like there really was a cosmological constant, but it wasn't acting to cause a steady state. It was acting to cause a massive expansion. But that's another. We'll get to that.
Okay.
Okay, if you like. So what I'm saying is, you had the observational evidence that showed an expansion. You had Einstein's equations. So you had these two nice things going together, and you got something called the Friedman Walker Lemaitre. Oh, there's one other guy. FLRW is that was the initial Big Bang model, and today, so as of 1980, where we got Cosmic Background Explorer, that was the initial. That was 1990, I think, and the WMAP evidence, that's the background radiation and all that. So there's just so much evidence behind it. The Big Bang theory predicts the proper element compositions in the universe, things like that.
Are you talking about?
It really looks like the universe. At least we'll make the humble statement: the bubble that we live in appeared to have an origin. Okay, so initially, and apply Occam's razor, you go back to 1980, 1990. In that period, the scientists back then said, well, hey, looks like there's a beginning to the universe. But the way that the subject, scientists like everything to be explained. Stephen Hawking is a great example of this. Okay, so that's why Stephen Hawking was a great proponent of looking for the theory of everything. You don't like things that are left unexplained. And that can get into the theism versus atheism debate.
Mm-hmm.
Okay, because what you, and this gets into the philosophy of science. And one of the questions I know you wanted to talk about is, can you be a scientist and a religious believer at the same time?
Mm-hmm.
And Richard Feynman, your audience probably knows who Richard Feynman is. He's the guy who was involved with the Columbia disaster. He was on that. He was the one who proved the O-rings were the cause of the disaster. He's a very famous scientist that quantum electrodynamics. He worked on the Manhattan Project. He would say, yeah, some of my friends are religious believers. There's a tension there. And he would say, and I don't necessarily agree with this, he would say that religious believers have to believe dogma, which means they're fed something and they have to accept it, and it's not a subject of testing. And so therefore, when the scientists, you're all about everything is tested, everything is to be tested, we need explanations for everything, and everything is just probabilities. Okay, so that there's this natural tension that he sees. And let's fold Stephen Hawking back into this. Hawking, he was firm advocate in the idea that things have to be explained. In fact, Hawking would say, and I'm going to paraphrase one of his quotes from his paper, I could find it for you, have it saved somewhere. He took to the position that just the fact that you could show that, let's say, the universe was past eternal, doesn't help you avoid God at all. Because what that does is it takes what's called a boundary condition, or really the arbitrary conditions for why the universe is the way it is. And if the universe had a beginning, that boundary condition, whatever it is, would apply at the beginning. And he would say, but if you have a past eternal model, there's still a boundary there with all these apparently arbitrary conditions. It's just that past infinity instead of this finite, this beginning of finite time in the past. So Hawking would say, having a past eternal or a beginningless model, and by the way, they're not necessarily the same thing. Past eternal and beginning can be different. He said that doesn't resolve the issue. You have to find explanations for things. Now, this is where I think kalam fits in nicely, in that it speaks specifically to a transcendent cause. So it says there must be something that transcends ontologically the universe.
Yeah.
And that is your explanation. And if you don't accept that explanation,
if you don't accept it,
it's difficult to argue at that point.
Yeah, absolutely. It seems like science is based on the view that things have a sufficient explanation. Things that happen, events have a sufficient explanation, and things don't just occur or change without an explanation. We automatically look for an explanation for things that occur in the world. So it seems to me, and correct me if I'm wrong, that the scientists, if they say that the universe doesn't have an explanation, they're not really, they're kind of being inconsistent with the whole scientific enterprise. Am I?
You end up there, I believe. Philosophically, it's sound. You can't argue in that. It's possible to argue in that direction. You can say the universe is a brute fact.
Mm-hmm.
Okay. In fact, there's theologians that would argue that God is a brute fact. I don't I don't think that their belief is like Richard Swinburne, for example, the cosmologist Donald Page. I think believes that he's a theist, but I think he believes that God is a brute fact.
Yeah.
So, from the theory of time that we're talking about, that would be like things that pop into being reasonlessly. And there's a significant problem with that. If we're going to say that science is our path to knowledge, that's where we get knowledge from.
Yeah.
Then what is science? A significant part of science is the ability to do repeatable experiments. For example, in order to find this, that you're taking a hammer and you're banging the universe and you're listening to it ringing, so to speak. And if one scientist in Moscow does that, and another one in New York does that, they should get similar answers within margins for error of experiments and things like that. So the thing about that is that the universe would have to be very predictable. It would have to be extremely ordered to do that. But you can't have it or reasonless phenomena that could occur. So the philosopher Robert Coons, said something about this that I find to be a forceful argument. He argued that if you had a reasonless process, or something that the universe, whatever, an electron, things that pop into being, okay, then probabilities don't apply to such processes, because probabilities imply reasons. Give you what the probabilities are, and you just said that there are no such things that apply. So it's a category error to apply a probability to these processes, like universes popping into being, electrons popping into being, experimental phenomenon under your microscope or telescope popping into being. So if you end up, the result of that is if we end up believing in reasonless processes, things that can pop into being, you can't get repeatable scientific experiments. You know what you're looking at. And and you can't say that it's unlikely that's what you're going to see, because by definition, there's no probability attached to it. So that leads back to the point that you just made. It becomes impossible to do science. It might be true, but you could never know it.
Well, I think this is a great way where philosophy, and I think William Lane Craig debating Dr. Carroll in that book you have, that, well, I'm not sure if Craig says this, but philosophically, and Thomas Aquinas and Aristotle discuss this, or being can't come from non-being. So because it doesn't even have the potentiality to do that. And I wanted your comment on something about the cause of the universe. This is from Christopher Isham. Are you familiar with Christopher Isham?
Yeah, he's a cosmologist. British.
This is what he says, and this is in quotes. Perhaps the best argument in favor of the thesis that the Big Bang supports theism is the obvious unease with which it is greeted by some atheist philosophers. At times, this has led scientific ideas such as continuous creation, or the steady state, or the oscillating universe, being advanced with a tenacity which so exceeds their intrinsic worth that can only suspect that the operation that there's the operation of psychological forces being very much deeper with the unusual academic desire of a theorist to support his or her theory. I find, and I want your input, when we talk about the initial beginning of the universe, I find a lot of physicists and being reluctant to accept the absolute beginning of the universe because of, well, philosophical viewpoints, or the smack of divine creation, as Stephen Hawking once said. What is your idea on that?
Well, part of that is what I already indicated. The scientists, a lot of them don't like the idea. You can't just saying God did it. How do I prove that? God's a free will being.
Yeah.
Okay, so I mean, how do you prove the probability that God would create the evil? There
Mm-hmm.
can't be, right? Because he's a free will being.
Yeah.
So
with unlimited resources at his disposal.
In physics, we like the physics of the pool table. Okay, so I got billiard balls knocking in with conservation of momentum off the 8 ball and the 9 ball, and they're all going the dirt. And I can predict where they're all going to go, and it's a completely closed, self-contained system, and I can describe all of it. That's what physicists like. They don't like this idea of, okay, there's something else out there, especially a free will being, that could explain it. Now, the Isham quote, there's another quote from cosmologist John Barrow in his book. I think it's the Book of Nothing. He has the Book of Infinity and the Book of Nothing. He's the one who wrote with Frank Tipler, the Cosmological.
Yeah, I have that book, by the way.
Oh, yeah, still excellent. 1986, but still.
Yeah, it's too technical for me to understand, though, except the first chapter.
The thing that Barrow, he said that, I don't necessarily agree with him, but he made the opposite point to Isham. He said that a lot of people are argued in favor of a beginning of the universe because they come from a Western and therefore Christian society. And so it's imposed upon them that they believe. Now, that doesn't seem true to me when I look at the hostility to the idea of a beginning. Back in the early 20th century, what you'll see, especially when Lemaitre was doing his work, and what you would see is cosmologists could warm to the idea of a Big Bang if you could just say, like the cosmologist Thomas Gold said, that, okay, you reach a point where you say things are as they are because they were as they were. And then we stop explanation at that point, and we don't worry about what happened before that in a causal sense.
Yeah.
And so that allowed people to embrace it and not have to get into the theological aspect. And remember Pope Pius in 1951 said, hey, this shows evidence for creation. They're trying to deal with that.
Yeah.
Okay, so that was the first way of thinking of it. And see, it's all mixed up with methodological materialism. It's really a way of doing the philosophy of science, which the two of us probably don't agree with. I don't agree with it.
Yeah.
But you don't admit God into your list of possible explanations. So if you do that, you're going to be like the Sherlock Holmes quote, which is that out of my list of materialistic possibilities, no matter how improbable, maybe cumulatively they all are, there's no other explanation. One of them's got to be true. That's kind of where you end up. Which is why I like the kalam argument, because it forces you to embrace a transcendent conclusion.
Well, I think it's very clear. Whatever begins to exist has a cause. The universe began to exist, therefore the universe has a cause. I think it's an argument that pretty much anybody can understand. There's of course way more technical things to the argument that you and others and Dr.
Oh, yeah.
Craig and others go into, but I think it really shows the initial probability, the basis, a good reason to believe that the universe did have a beginning, and that beginning needs to be explained by either material processes or a mind. So I think it's a really successful argument.
I would call it a successful argument. Dr. Craig would call it a successful argument. We wouldn't call it a knockdown argument.
Yeah.
Dr. Craig is very careful to explain it this way. He would say, it seems upon reflection that that each premise is more likely than not to be true, and therefore the conclusion follows from the premises. That's the way he would say it.
Uh-huh. He's very modest.
It's not. Yeah, so it's not a knockdown argument. I could sit here and put on my red team hat, so to speak, and go through all the sophisticated objections, which is essentially what my articles are about. Is to say, no, I'm going to be like the INTJ. I'm going to say, I want to prove every damn thing. Say, oh, okay, you say the hot. Okay, sorry for my language. But,
you're good. I before we go on,
sometimes we'll get into the earthy language. What I want to do is say, oh, okay, the hot Big Bang theory. What are the objections to the hot Big Bang theory? Because there was a singularity theorem from Penrose and Hawking that said if gravity is an attractive force, then I can show you, based on the characteristics of the universe, that there's a singularity in the finite past. If general relativity is true, if gravity is attractive, and there's this list of conditions that they have, and some of them are sophisticated things like that energy conditions that are sophisticated.
And I think that was the 1973 article, or I forgot when it was, in the 70s or 80s.
I think it was. The two of them collaborated on a lot.
Yeah.
Singularity or incompleteness theorems would be the more general term, which mostly had to do with black hole studies.
Yeah.
Hole studies. If you talk to Sarah Salviander, who's on also.
Yeah, I hope to talk to her soon. Now, before we go on to the cosmic fine-tuning argument, that those things that show that the universe is plausibly designed, I want to ask you about the in 2003, Alexander Vilenkin, Guth, and Borg. Vilenkin had this quote. It is, and this is in quote, and Craig has used this many times. I want your view on it. He says, "It is said that an argument is what convinces reasonable men, and a proof is what it takes to convince even an unreasonable man. With the proof now in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning." Do you have any comment on that 2003 paper?
Yeah, we've.
Maybe it's 2006.
The theorem was actually derived in 2001, and they published it in 2003. And it's not that controversial, really. What it shows is, if on average the universe is expanding, then there's a beginning to finite past.
Okay.
But it's also purely general relativity. So what's one of the objections? Oh, quantum gravity is out there. So let me tell you a little bit about Vilenkin. I've talked a lot with Vilenkin over the years. So he's not a theist. If the quote that you...
It's from
his book.
Yeah, Many Worlds in One on page 176.
Yeah, which I definitely recommend. Okay, it's worth reading. Vilenkin does believe that the universe likely did have a beginning. Now, he came out with a theory of quantum gravity called the tunneling from nothing theory in 1983, the same year, actually it was 82 or 83, just about the same time that Stephen Hawking and James Hartle came out with their quantum mechanical model of the universe, what they call the no boundary model. Okay, so Vilenkin believes that quantum mechanically there was an origin. So what he believes is that this 2003 singularity, or really it's an incompleteness theorem from Guth, Bourdet, and himself. He believes that would show from general relativity that it's pointing toward an origin, and the origin is quantum beginning, this tunneling from nothing from 1983. So, and the way that Vilenkin argues, which is similar to some of the arguments that we use, and we naturally, because he is a famous cosmologist and one of the foremost in the world, we use his work. What he'll do is he'll look at different classes of models. What he'll say is, aha, my theorem here, my 2003 theorem with my colleagues, shows that there's different classes of models. There's models that are expanding on average. There's models that could be contracting on average. There's models that we could say are static to the past. Asymptotically static would be the term, okay, which would evade the theorem. And then there's a fourth class, which this is a little tricky, but a lot of modern cosmologists argue for this. They would argue that that you get back in a finite time, if you look backwards, you reach a point, and this gets into your entropy argument a little bit, which we haven't talked about yet. We got to get back to that the arrow of time turns in the other direction. It's a really unusual phenomenon. Okay. A model like that, and there are some cosmological models that have that structure, would evade the BVG theorem, the one that we've been talking about. So what Vilenkin then does, okay, and in his book he does this to a degree, but in his academic papers, most of them you can get preprint online, the preprint versions. He'll go through each class of those models. Well, what about the static models? What about the contracting models? What about the reversal of the arrow of time models? And he will give separate arguments why he thinks that each one of those doesn't pan out. Okay, they're not knockdown arguments. When you get all the way down into the weeds and the sophistication and what the cosmologists are talking about to themselves, what you get are likelihoods. You don't get metaphysical certainty.
Yeah.
So what you're seeing is a quote, which is what he believes that it's likely that the evidence shows. And this is the way I like to speak to it also, especially so that we don't get an accusation from our philosophical opponents that
we're too dogmatic,
that we're overspeaking the case. I would say, as Vilenkin does in his academic writings, that it looks like these static models are unstable. That's the argument he'll use against them. So they can't be past eternity, because I can't make something that's unstable last for all eternity, because by definition it's unstable and it has to break down, right?
Because they're in small perturbations would make these initial cosmological singularities or expanding universes collapse in on itself.
Yes.
Okay.
Let me just talk about that a little bit. Okay. A way of overcoming this idea. So we look and we see the evidence, like we with our telescopes, that the universe is expanding, and we say the universe is expanding on average. Therefore, I can apply this theorem, which nobody really disagrees with. I mean, they believe there's exceptions to it, but they don't really question the validity of the theorem itself. They say, okay, we're expanding. The theorem that everyone thinks is fine says that things that expand on average have a beginning. Therefore, we've got a beginning, right? Well, no, you can set up constructs. Now, to me, looking from outside, that kind of looks like special pleading. Can I construct a model which is not on average expanding, even if it has expansion in it? And the answer is yes. And the way you do that is you say that it's expanded a finite amount over infinite time. So on average, the expansion is 0. So I don't want to call it a mathematical trick. It's a valid thing you can do in mathematics. These are the way that these models are structured.
Yeah.
Okay, so that's what you have to do first. So that's the first problem you have to overcome. And like I said, it seems to me like special pleading to do that. But can you do it? Yeah, you can just say, yeah, that's what happened. That's fabulous. Okay. The second thing you got to do, though, is that by definition, it was static. You had a universe that was not expanding for all eternity. And then suddenly, one day, it just started expanding. Okay, so how does that happen? And what you can do is you can say, well, there's this potential, there's this energy thing. It's like think of like a perturbation that starts off really weak. And eventually it gets, and it just, for whatever reason, brute reason. Okay, there's no reason behind. There's not an explanation behind it. What they'll say is this thing is growing for all eternity, and so it grows a finite amount over. It's the same kind of mathematical structure as that allows me to have past eternality in the expansion. They say there's this field that grows that way until it gets strong enough, the pot starts boiling, and the universe takes off into expansion. Can I say as a brute fact that thing might exist? Yeah, you could say just about anything is a brute fact. Okay, but these are the way these things are structured, and you can't look at it and say, logic error, or this is definitely ruled out by this. You can make that construct. What Vilenkin and his collaborators do, he's worked with at least one lady on this, one of her papers, but there's, I think Anthony Aguirre separately has written on this topic. He's famous cosmologist. They will argue that quantum mechanically, that these systems are still unstable. That the nice structure that you tried to set up, that for all eternity the potential doesn't upset the pot, and it stays stable. They'll say that doesn't work. Quantum mechanically, the whole thing's going to undergo through a phase state, and and in fact, you're going to revisit singular conditions. But now it's a quantum singularity instead of a general. So, sorry if I got too far in the weeds on that, but I wanted to give you an idea of this. These are the kind of models. In fact, when Dr. Carroll was debating Dr. Craig, it was 2014, I think. One of the things he did is he said, I'll show you. Oh, you think that there's no beginningless models? I'll show you beginningless models. And he put up this list. And a lot of these, and it had like 42 items on it or something like that. And we didn't get a chance to rebut it. Okay. And I put out something on my Twitter about this. But really, the argument that we make in reverse to deal with that is to say there's not 40. First of all, I don't have to disprove your 142 or whatever your number of models. Okay. Really, all these things fit into a class. Things like expanding, contracting. The other things is a lot of these have to do with alternative theories of gravity. They have to do with saying, well, Einstein's not good enough on his own, for example. So we're going to make adjustments to the Einstein's equation. And if I make a suitable adjustment, now I don't get a singular prediction and I can go before the Big Bang, so to speak.
I apologize. Give me 1 second. I have a small emergency on my feet. Let me, 1 second. I apologize. Michelle? everything's fine. I'm so sorry to interrupt you. Um, uh, my wife was doing something. I thought she called for me an emergency. It was nothing. Everything was fine. You were talking about there's no real probabilities to these other models, or these
Well,
models. You
what I was
didn't get a
saying is
chance to
that
rebut it.
what I was saying is a lot of these models, you have to say, well, I'm going to make adjustments to Einstein's equations in order to upset. There's this thing called the Einstein static state. That was Einstein's original model that I spoke to, which was a static universe, meaning it was not expanding or contracting. The problem was it was unstable. The tiniest little perturbation, it's like a ball resting on top of a hill. As soon as you touch the ball, it's going to roll down the hill, right? So that's one of the problems with these models. So what you have to do is you have to create what's called a gravitational potential, which is stable. That would be like a marble rolling around inside a cereal bowl. So the cereal bowl keeps the state stable. What you need to do or make adjustments to these theories to allow for these asymptotically static models to work. Okay, so can you do that? Yes, but the moment you do that, you're stepping away from all the abundant evidence for Einstein's general relativity. But you don't want to. You want to stay with the thing that has the general relativity is probably third on the list of the most impressively proved theories that are out there.
Yeah.
So what I'm saying is the list that you can put up that opposes that isn't really that impressive if you know what it is.
Yeah.
Okay. So there are a bunch of categories that either we've dealt with in our publications or Vilenkin has dealt with in terms of classes. I don't care about your individual models, they fit into a class. Or you're making these adjustments away from the proven theories, which you can do, but the moment you do that, you're stepping away, you're making an extrapolation away from the things that are proven.
It did seem like Sean Carroll, when he brought up that, there may be so many different models you can give, but not all these models are as probable and common sense and consistent with the general theory of relativity as the standard Big Bang model. Is that a fair characterization?
I said you have to start making these extrapolations, similar to how we were talking about Fred Hoyle before, where in the mid-20th century, they said, well, can I have a steady state model that deals with the fact that our I'll just call it the local universe to be humble, appears to be expanding as opposed to an inflationary bubble, right? or something like that. And can I do things like, the heliocentric versus the Ptolemaic? Can I do things to theories by making adjustments that they still fit with observation, or they fit with a metaphysical assumption that I have past eternality, something like that?
Yeah.
Okay. Yes, you can do that, but now your extrapolations are leading you away from Occam's razor into
I see.
more dangerous. So this is where you end up. Can you do it? Yes.
It seems what you're talking about is it's the more that you list these different models and different approaches, it's more speculative than the standard, more common sense interpretation of the general theory of relativity.
Yeah, I would say that. Now, it's not quite right to say, oh, these people just have it in for God and they really have hostility to that hypothesis, and they just don't want to consider it up front. It's more like, for the last 100 or so years, the academic environment in the West is you just don't consider God as an explanation. So people are used to that. It's methodological naturalism. And I said the other one is that physicists have a bias toward I want to explain everything. I hate it. I can't understand what's going on.
Has a lot of personality with individual physicists too. Wanting to try to prove everything. Now, we've spent a lot of time on this. Just briefly, or not. I wanted to ask you about the cosmic fine-tuning. This is another great argument for the existence of God. There is a law like it. It appears to me, and philosophers and physicists far smarter than me have said that there is a law-like structure to our universe, and it seems, at least to some, that the law-like structure seems better explained under theism than atheism. Now, that law-like structure that makes possible the eventual emergence of life, the eventual evolution of life. We're talking about constants and quantities at the initial Big Bang, and so forth, other ways to perceive design in the universe. Can you introduce that and maybe share a few of these constants and quantities that makes the existence of life very, very improbable? It seems like it was designed for the eventual emergence of life. Can you share anything with that?
Yeah. I mean, do you want a really short description?
Um,
Or,
Medium length, I guess.
okay. Because this is, I think Brandon Carter is the cosmologist that in the 70s wrote an article on this about the strange. I think he called it the strange coincidences. I don't remember the exact.
Are you talking about the anthropic principle?
Yeah, anthropic principle. It's the idea that the universe appears designed, and there's several different arguments. We're only going to talk one. Like Reasons to Believe would have an argument that Earth as a life site is fine-tuned. Also, that's that's one.
Yeah.
Put that over here. Then there's a separate argument, which would be that there's things called free parameters within the laws of physics, like like the standard model particle physics. The masses of the particles, the force strengths. You asked me to get into some of these specific. Now, if you go to my Twitter site, for example, just look for James Sinclair Twitter. Actually, you have a link on your site to it. I give several of these examples because the best example of it is the really exquisite balance in stars like the sun. Okay, and how you get the force strengths are exactly set. Like, why doesn't the sun just collapse? It's an extremely heavy object, and gravity attracts. Why doesn't it actually just go straight to minimum compact size for objects of that mass? And the answer is no. There's this really careful balance between radiation pressure pushing outward, which are other forces than gravity, and gravity itself. And there's a series of these fine tunings. And there's a guy named, a cosmologist named Luke Barnes and Geraint Lewis, I think is his name, that wrote a book in 2016. That's probably the most up-to-date work on we'll call it the apparent fine tuning, okay? Because we want to be humble about this. All right,
yeah.
So, and bring the atheists into the conversation. It's apparent fine tuning, and then what do you do with that? What does it mean? It looks like I had a presentation that I would give sometimes. If you go back to the 1950s or something like that, and they'd say, well, gee, we're starting to learn enough about the different forces of physics to wonder about, hey, what if we tweak this a little bit and tweak that a little bit? And the thinking would be, well, then the universe would be a little bit different and life would evolve differently. Okay. But you still got life, right?
Yeah.
And what they discovered is that it's almost possibly small parameter spaces that permit any kind of life at all. Like one of the fine-tuned things is the expansion of the universe itself. Because you have to get the situation, if the universe, it starts expanding, And think of it like the cosmic explosion.
Okay.
Okay, if the universe is, on average, its density of mass, if it's too dense, it's just going to collapse back in on itself into a singularity. If I just talk about general relativity here, okay, instead of quantum gravity or something. I'm always talking in terms of a model. Okay, the structure.
Yeah.
Right. So that doesn't permit life. On the other hand, if if the universe expands too quickly, then you can't precipitate out matter into galaxies and stars and planet Earths and life and all that either. And it turns out that the balance that you get appears exquisitely fine-tuned. That if I was just making universes randomly, I had a universe generator and I was just spitting them out, almost none of them would permit life. Okay, so this just seems like a remarkable fact, but it's just one fact. We got lucky on that one. Thanks. That's fabulous. Okay, but then you see, well, it's not just that. There's also what we say in our, there's a paper that the Catholic priest, Jesuit, Robert Spitzer and I published in 2018. It's called Fine Tuning and Indications of Transcendent Intelligence. It's in a philosophy book, which Graham Oppie was one of the editors, famous atheist philosopher, and Jeffrey Kotursky, I think, is the other one, Fordham University. Okay, so, it's Theism and Atheism, Opposing Arguments in Philosophy, I think was the title of it. Okay, and in there, we're discussing some of these parameters, and one of them is it's not just the mass. It's also there has to be enough non-uniformity in the structure in the beginning to precipitate out the galaxies properly. Otherwise, you also don't get it. And
are you talking about homogeneity?
Yes, and you can see that in the WMAP evidence and the Planck satellite evidence. It's the cosmic background radiation. If you look at the patterns of temperature in different directions, what you really are seeing is different density perturbations. And it occurs at, I think, about 1 part in 100,000. And that could be a free parameter. All right, so there's a series of these things. They said the force strengths, the masses of the particles, and they're not just fine-tuned one way. They're fine-tuned. A lot of these things are fine-tuned like 7 or 8 different ways for different purposes. So the more you look at this, the more impressive it gets. The example that is often given by Christian philosophers is the example of the firing squad. Okay, so what you'll say from a scientific, and Aaron's talking about methodological naturalism, is what we'll say, well, anthropic principle. The anthropic principle is pretty much that, well, we wouldn't be seeing this in the first place unless we were in a life amenable location, right? So it's not spectacular at all. Well, imagine now that this is the argument, this is called the weak anthropic principle. Okay. That I'm in front of a firing squad. There's 8 expert marksmen. I close my eyes and they shoot. And then I'm like unharmed.
Now, immediately,
I would think that, well, gee, isn't it wonderful how lucky that I am? Or would you think, I'm talking in terms of explanations, would you think, my parents paid off the firing squad? Like that. This is why, for example, a winner of a lottery cannot be part of the family of whoever's in charge of the lottery, because it's just too fantastic. It wasn't fixed. Okay, so what you're looking at is the argument circa 1970s, weak anthropic principle. So that's the atheist reply, and that's the Christian reply. And then finally there's just so many of these things and they're so impressive. That's where the idea of the multiverse comes in. To say, well, fine, there's infinite universes, or however many that we need. It's not that simple. There's certain physical processes like cosmic inflation, which is cosmic inflation is essentially gravity that pushes away, repulsive gravity. It makes instead of attracting, the apple falls from the tree, Isaac Newton.
Mm-hmm.
It pushes things apart. Okay, so there's
Okay.
there's certain types of energy that can push things apart. Okay, so you can get what was the I forgot. I lost my train of thought.
The multiverse we're talking about.
Where does the
Yeah.
multiverse come from? Yes. The certain inflationary theories would naturally predict multiple inflationary bubbles, which you can think of as separate universes.
Mm-hmm.
Okay, so that muddles the topic a little bit. And in fact, let me see if you see this book.
Okay. What is the title of that book? Oh, by John Leslie, Universes.
Yes.
Okay.
This is the best book out there. It was written in 1989, and you think, oh, that's a long time ago. No, this is still the best book on this topic. And there's lots of books out there. I just mentioned one by Lewis and Barnes,
Mm-hmm.
which is excellent. But this, I think, is the best. Leslie is a philosopher.
Yeah.
He's a philosopher who knows a lot about physics, which is a great combination. And so he talks about all these, the primary theories that are still in existence today, which are still dominating the discussion, were there in the 80s. I've mentioned a couple of them: the Hawking-Hartle model, the no boundary model,
The oscillating,
the tunneling from nothing from Vilenkin, and inflationary models. Now, the different inflationary, the chaotic inflationary model, which is the dominant version that people accept today, for Andre Linde, the
Russian astrophysicist.
Yeah, that was you get refined models in the 90s. But what I'm saying is the primary ideas were already out there when Leslie wrote this book, and you can still get it hardcover. You can get it on Kindle too. But the thing is, he explains the discussion very well. Okay, and the beginning of the discussion, he uses an example of three people on a desert island, and one of them has a treasure chest. So let's say it's Bob owns the treasure chest, and then there's Sue and Robert. Okay, so Bob goes to sleep one night, wakes up, his treasure chest is empty. And where did the treasure go? Okay, it wasn't him. So either Sue or Robert, or both of them together, robbed him. Okay, so what happened is the fact of the empty treasure chest lends plausibility to all three of those hypotheses together. So the way that fits is that the fine tuning, and this is what Leslie would argue, is he would argue that this is the start of the follow-on argument post 1989. Is there is now evidence for a transcendent creator. At the same time, it's offering evidence in favor of multiverse, and it's also offering evidence of a God-created multiverse. All three of those hypotheses are in play based on the fine-tuning evidence. And you can't simply explain it away like some philosophers like Victor Stenger would argue. He wrote a book called The Fallacy of Fine-Tuning, which he said that he tried to argue that it was a subjective construct. It was a social construct, I think, rather than an objective phenomenon.
Our minds are wired to see patterns in laws.
It wasn't a silly thing to argue. It was something that was worth pursuing. But we mentioned that in our article, Father Spitzer and I briefly about that. Let's see. I was talking about, okay, so where the discussion is now, it's all about what's the explanatory power of a multiverse. So, because
that's what atheists love to go back, and I've heard this a lot. Well, perhaps the universe is eternal. There's an infinite amount of different universes, and just wanted to bring that to the audience.
And it's worth discussing, because I said, if you're like me, then you want to painstakingly work out all the things, and you want to believe things based on evidence to the best of your degree. Now, I said, when you get back to faith, you say, I hold the Christian, where you get your faith, properly basic belief that comes from the Holy Spirit. Okay, gift of the Holy Spirit. Okay, you cannot argue someone into the kingdom of God.
Yeah.
But, it doesn't hurt to have some physical evidence, because as I discuss, where is that? Holding it. Okay. This is the book that came out from the Greer Herd debate between Sean Carroll, famous cosmologist, maybe the greatest living cosmologist. I really believe that. And Dr. William Lane Craig, my collaborative philosopher. Philosopher knows a lot about physics. Good example. A good combination. Okay. So
what do you think? Like John Leslie, and the prevalent view, because I hear, even just so many, people like Lawrence Krauss, for example, and say that. Do you think it's a simpler explanation to postulate one universe? Maybe Occam's razor would say not to multiply causes beyond necessity, and maybe we should look at one universe, or God caused one universe.
right,
Do
I think that's perfectly viable myself, but you're back in the Sherlock Holmes conundrum. If you're not going to permit God as an explanation, then I don't care how improbable the other explanations are. One of them is going to be true. So that's kind of where you are. If you go back, I don't know, 1960 or something. Okay, what were the discussions that you're making? The simplest argument is that there's one universe. Okay, can there be more? Well, it turned out there was more. There was probably a cosmological constant or some type of energy of that type. But it's not impossible that you can get more complication. But what it seems more like is that there's a refinement of the Big Bang Theory going on, rather than a full overturning. And
okay. Yeah.
You have to keep adding these things like, okay, now I want to construct a multiverse so that I can attempt to avoid the problems with the anthropic principle.
Yeah.
Okay, if it's the question that's out there is how natural is that? Many physicists would say, hey, I've got predictions coming from the model itself, say the inflationary model, that seem to indicate that I could get a multiverse naturally. So I'm not doing special pleading, okay, even though it fits in with my philosophy of science. So the place where the argument went to, and a lot of the 2018 article that Father Spitzer and I published, if you want to talk about the Boltzmann brain issue, you said you wanted to talk about how fine-tuning gets into. You say, well, okay, fine. There's a lot of experimental evidence that inflation seems to be a process in nature that really happened. It's the dominant model that's out there, and for a reason. And the thing is that, and I'm going to paraphrase an inflationary cosmologist named Raphael Busso from the early aughts. He said, look, I want to discuss today two ways that you get structure in nature. And the first way is evolutionary, where you've got an expanding universe, say, and galaxies precipitate out of that mass, and you get stars and eventually planet Earth, and that's where life comes from, et cetera, et cetera. Straight evolution. Things change with respect to time according to laws of physics. The other way you can do it is it can just pop into being. Now, this isn't the same kind of pop into being we're talking about before. This is not a reasonless process. This is what's called a thermal fluctuation. In an inflationary model, a model with this special kind of energy that makes the universe want to expand like a bat out of hell, you get these things called thermal fluctuations, and these fluctuations can be anything. And you can get an entire solar system like ours just pop into being according to these thermal fluctuations. Now, it's not very likely because these occur according to a probability, according to how much complexity is in the structure. So the less complexity you get, the more likely they are. So the problem you get into is this. This is where the fine-tuning argument has gone.
Okay.
That I brought you through it from the 60s to the 70s to the 80s. And finally, you get into where are we in the 2010s and the 2020s. And where you are is a philosophical thing. When do I have rational justification to believe in my own physical theories? Because here's what we want to believe. What we really want to believe is that we're these things called ordinary observers, OOs, that we are evolved creatures. And here, I'm not talking about Darwin's theory of biology. What I'm talking about is general evolution. I'm talking about time passes, physics acts on things, they change. They say you got a big bang, or you get galaxies, stars, planets, etc., and all that, and finally life. We want to believe that we're these ordinary observers that are sitting here doing science experiments, and that when we look in telescopes and we look back in time, because that's what you're doing when you look at distant objects, you're seeing things as they looked 10 billion years ago or something. Billion years ago. Okay, so as opposed to 5 minutes ago, I popped into being as a thermal fluctuation. Because if 5 minutes ago I popped into being as a thermal fluctuation, I can't believe anything that I'm seeing, right? The past is a lie to me. It's a thing that it's an illusion. Okay? So we have this problem of rational justification in what we see. Because what does it come back to? We talked about this earlier. If science lends itself as a true knowledge-based knowledge-generating activity, then I better be that ordinary observer. So, and the problem is that inflationary models in general, what I'll call naive inflationary models, spit out these what we call freak observers like crazy. So much so that there's a lot more of them predicted over the course of the history of an inflationary bubble, or our local universe is another way to put it. So from a let's just count the numbers perspective, how does this, by the way, why does that happen? Because there's a sweet spot in the history of a Big Bang universe where life can exist. Too early, you can't exist. Too late, everything spreads apart, thermodynamics, energy all disappears. You get the heat death of the universe, and you don't get any more evolution going on that leads to life. But what you do get, because it's based on the cosmological constant, the thing that's causing the inflation, which is not a function of space and time, right? It just is a constant by definition. You get these freak observers throughout the whole history of the universe, even when it's cold and death otherwise. So there's a lot more of them than there are OOs, ordinary observers. So in other words, inflation might be true, but you don't know it because you don't know whether you are one of these freak observers. So it was cosmologist Donald Page who really got this rolling, I think in the late aughts. He wrote some famous papers on this, trying to solve this problem ever since. And here we get into what's called these things called Boltzmann brains, these freak observers. A Boltzmann brain is a human brain that just appears in deep space as one of these thermal fluctuations, thinks a few thoughts, and then freezes and dies or something. Okay? Right? And that can happen complete with false memories. Like you're in the Matrix or something. Okay, so those are much more likely than entire galaxies or solar systems would appear, or fine-tuned Earths or things like that. Okay, so the thing is it's inflationary theory that's driving the most impressive idea behind a multiverse. This is the one that says, hey, we got to take a look at this. But that has this Boltzmann brain problem. So over the last decade plus, what you're seeing is a really serious effort to try to prove that ordinary observers can somehow dominate in these inflationary universe. And there's a larger philosophical mathematical problem called the measure problem, which applies here, which is where you get, if you got infinite numbers of things, how do you compare them? Okay. Which applies to, which I'm not going to get into in detail. But the idea of how you compare infinite populations, is also a problem here. So if I'm going to have rational justification in my belief, how am I accepting that these multiverses exist? I cite Father Spitzer and I, we quote a paper from Donald Page where he mentions 245 separate theories that try to resolve the Boltzmann brain problem. And that's the problem with it, isn't that they can't figure out a way to do it. It's that there's 200, they all have their own pet theories on how to do it. So it ends up seeming like this isn't really doable. What that comes back to is the multiverse really viable as a theoretical idea? And here we're talking strictly in this inflationary context for simplicity. And if it isn't, then where am I? Okay, am I back to, and oh, by the way, the multiverse in a theistic concept, this Boltzmann brain problem ain't a problem at all. Okay, so it's only a problem when you're trying to make this rational justification for how you can get.
It seems like you're talking about verifiability, how the like Donald Page and so forth can verify it with in the scientific process that the ordinary observer is the one that's observing, the past and our having our memories. There's no way in the scientific understanding to verify that, but there is a way by common sense, by the things we take for granted in everyday life. Is that kind of how you're trying to contrast it?
Yeah, I mean, and what you're getting into is even a larger thing. And if you go through that volume, the Blackwell Companion.
Blackwell Companion to Natural Theology. Oh, you have one too. Okay.
Yeah,
of course you have one.
I hate that cover. The different arguments in there for the existence of God, because I'm only talked about two of them, and there's a lot more of them in there. A lot of them could go into this category, like it's a transcendental argument, which is it's not a knockdown argument. What it is it's of this form. If it's possible to know anything, then God exists. Okay, so the evolutionary argument against atheism, for example, that's one of the arguments in here.
Yeah. Right, Alvin Plantinga, right?
Right. Plantinga. So there's a version of that in here. The argument from consciousness, the argument from reason, Victor Reppert. A lot of these things end up where do we believe that we can, not just can I do science, but do we believe that we can do things?
Yeah.
Okay, so it gets back to that presuppositional argument.
Yeah. That rational justification, that a person can be rational even if they can't scientifically, quote unquote, prove that we're the ordinary observer, or that we're not just a Boltzmann brain, but we're an
I think single universe inflationary theories work just fine, and that's the thing that you have evidence for. And if and the nice thing about the tensed or A theory of time that we were talking about that fits in the Kalam argument is that that just is evolution. Okay, I mean what I call capital E evolution. Things change with respect to time according to the laws of physics. Okay, so that's just metaphysically just what is going on. Okay, so evolution happens, and we are the universe itself ultimately is comes from that process, and it's a lot easier from that particular philosophical standpoint to explain what's going on, to epistemically, not ontologically, epistemically, it fits the facts of what science is showing us, the standard model of particle physics, the hot Big Bang theory, the experimental evidence for general and special relativity. If you don't go the Sherlock Holmes route and say, no God, that's not an explanation, so one of these other things has to be true because something must be true. If you allow God in as possible explanation, it fits the facts. It's a very satisfying worldview from that perspective. And you take that, and on top of that, the Kalam argument, which seems to show directly a transcendent cause. That works on top of that. It actually feeds the other one.
We're probably going to end it because we've been talking about an hour and 30. So many great points. So much to think about. I've done a lot of reading on this. It was just it's so great to talk to an expert, and I really appreciate how you explain things. Earlier, I think you mentioned a cumulative case. For theism or something of that, and that's how I like to argue that we can't prove these things with mathematical certainty, but we can give a cumulative common sense perspective on these things, this Boltzmann brains problems, this multi-universe problem, this Occam's razor, not to multiply causes beyond necessity, the origin of the universe. It seems that the problems are on the atheist side, and when you look at reality from a theistic viewpoint, it seems to fit like a hand in a glove. It seems to cohere and be more commonsensical. I wanted to thank you. Do you have any last words about what I said, or about any lasting impressions? Any closing words you might want to say?
Yeah, just that.
Because we talked about so much. It's kind of hard to give a closing, but the title is Theism, Atheism, and Big Bang Cosmology, and I said we were talking about the cosmic fine tuning, and I just think it fits better in an overall cumulative case for theism rather than atheism. Go ahead, James.
Yeah, I mean, those are what I think of as the two main arguments, other than the resurrection argument.
Yeah.
So you just go to where the sound, or you hear the sound of the guns, to use a battle. That's why I got involved in those two. But there's a lot of other excellent arguments out there, and you put it well. But you got to. None of these are knockdown arguments. There's nothing that you're going to talk to another person. You're going to argue them directly into the kingdom of God.
Yeah.
But if I was an atheist, okay, and I mentioned this in the God and Cosmology book, in the article, that I did. I wouldn't be satisfied with sitting back and saying, look, I'm the default position. I don't have to prove anything. Burden of proof is on you.
Mm-hmm.
I'm a natural physicist. We talk about this. I need explanations for things.
Mm-hmm.
I want positive arguments for why I think atheism is true, if I was coming from that perspective. And I'd also would go, if I was doing that, I would go to the hiddenness argument and the argument from evil. And there are some positive arguments in favor of atheism. But I would be heavily involved in the same kind of things that I'm doing anyway. I want to see where the evidence seems to lie. I want to see where, what seems to be the most plausible. What is it possible to know about these things?
That humble approach. It's a very.
Do it that way. And these are. When we talk to each other, I can't show you what's in my heart. I can't show you the Holy Spirit's there, right? I can't show you this properly basic knowledge and that he's witnessing to me and all that. What can you do? I can talk about the publicly available information, and the atheist can talk about the publicly available information. What is that? That's precisely the things that we've been talking about, and that's why we're involved in this conversation.
Well, that's great. I love apologetics. It opens up so much stuff, so many avenues. In fact, the more I learn, the more I read, the less intelligent I feel. So, because I just think there's a wide, spectrum of knowledge. I think we all have to be humble in the apparent design of the universe, the apparent beginning of the universe. It shouldn't just be an academic affair. It should cause us awe, and it should bring about humility in us. Go ahead.
That's why I love that Christian song, God of Wonders, because it brings you exactly to that mindset. And I've reached that position a lot, where you reach a point and say, I can't go any farther than this. This is too big for me. That happens to all of us. And you pursue these rabbit trails as far as they can. You do your best. Meanwhile, you have to live life, don't you? So,
well, I've interviewed two two scientists, one a biochemist and one a physicist, and they both think Christianity is compatible with science, and I think that really strengthens a lot of people. I think apologetics tears down a lot of these false idols of intellectual smokescreens that people have made. They keep them from coming to reality with a humble approach. And your work and Dr. Craig's work has really helped a lot of people, to try to look at the implications of the beginning of the universe and the apparent fine-tuning of the universe, and seek an explanation that's not just material. So thank you for your work, James Sinclair. Thank you.
Hey, thanks for inviting me.
Well, this has been the Christian Resistance, and I appreciate everybody for watching. Our main mission here is to proclaim the gospel of Jesus Christ, and that's our first mission. So thank you for everybody for watching, and God bless you all. Bye-bye. Let me end this.